Hey everybody, welcome to another Con Support video. This one's on linear equation word problems. Let's go. Okay, it says a young sumo wrestler goes on a special diet to gain weight. The variable W models the wrestler's weight in kilograms after the wrestler has been on a special diet for T months. Okay, so the equation they're giving us here is W is equal to 80 plus 5.4 T. So as the time in months goes up, obviously his weight increases. All right, so this is his weight in pounds or kilograms. Okay, so there's our equation. It says how much weight does the wrestler gain every 2 months? Well, if we set the T for 2, then we're going to find out how much the weight gain will be every T months, okay? So the variable is the weight because after the wrestler has been on diet for T months, okay? So when we're talking about the amount of weight he's gaining, let's just talk about the components here on our linear function. So this is your y-intercept. This is your b value, right? So this is where it starts. So the weight is the total weight that this wrestler has. The value that where it starts at is 80. So basically he starts with 80 kilograms as his weight, and then he's trying to gain weight with a special diet, right? And he's gaining at a rate of 5.4 kilograms every month, okay? So and when we're looking at the components here, this 80 plus is the starting weight. This is the amount that is growing at this rate, 5.4 kilograms of weight per month. And then together, that total is the weight that this wrestler has at different amounts of months. So it says, how much weight does the wrestler gain every 2 months? You don't really have to solve for W. You just have to figure out what 2 times 5.4 is, right? Because that's the amount that he's gaining, right? So this is the amount of gain, right? This is his gain. So after 2 months, you would have gained 5.4 times 2, which is 10.8, okay? So every 2 months, he's gaining 10.8 kilograms. So how much weight does the wrestler gain every 2 months? I would say 10.8 kilograms. Right? Because that is the starting value, right? That's his initial weight. And then this is the gain that he's having. All right, so the next story here says Rachel is a stunt driver and she's escaping from a building that is about to explode. Well, that's pretty scary. The variable D models Rachel's distance from her exit in meters T seconds after the cameras begin recording the stunt. Okay, so D is equal to negative 38T plus 220. So this starting value here, the y-intercept, is going to be basically how far she is from the exit, right? So that's basically the starting distance, right? So you can think of that as the starting distance to the exit. All right, and then every period of time, which in this case happens to be seconds, I believe. Yep. So every period of time, she's basically reducing that distance by 38 units of distance. Meters, I guess, is what it is. All right, so this is her basically movement towards the exit. Right? This is her change, rate of change. And then the distance is the total distance of where she's at, right? So after T seconds, how far is she from the exit, basically? Okay, so this is the distance to the exit, right? And then obviously the T is the number of seconds that have gone by, right? That's the number of seconds that gone by. So now we can talk about this different situations here. So this is what is Rachel's speed? So the speed is going to be the slope, and the slope is right here. It's negative 38. So it basically she's traveling a distance. So even though it's a negative slope, it actually is going to be a positive speed. Okay, because there's no such thing as a negative speed, particularly, because your distance is always positive. So yes, she's reducing the amount of distance to the exit every period of time at 38 meters per second. So I would say this is 38. Okay. And you might be thinking, why is it not negative 38? And like I said, it's because distance is always positive, right? So she's moving at 38 meters per second towards the exit. So her distance to the exit is being reduced, right? That's why it's a negative 38 multiplier, but she's still moving at 38 meters per second. All right. The next problem says Ever since Renata moved to her new home, she's been keeping track of the height of the tree outside her window. Says the variable h models the height of the tree in centimeters, t years since Renata moved in. Okay, so h is equal to 210 plus 33 times t. So what this is saying is that our initial starting value, the y-intercept here, is the height of the tree when she moved in, right? So this is where it starts. And so this is the height of the tree when she moved in, of tree when she moved in. And then the plus 33t is the rate of growth. So this is how it's growing. Okay, so this is how it grows, and this is, of course, it's growing at 33 centimeters per period of time, which is years, right? So it's growing at basically this rate, right? And then the h is the total height, right? So wherever it started, it's growing at 33 centimeters per year. And where does it end up at the end of those periods of time in terms of total height? So it says, how tall was the tree when Renata moved in? Well, that's just the starting value, right? The 210. So it's when time is 0, right? When t is equal to 0, that's the initial value of the tree. And the initial value of the tree was 210. So it's 210 centimeters tall. And then this next one says, let's just move down here. A big ship drops its anchor. The variable L models the anchor's elevation in meters relative to the water surface 2 seconds after the ship drops its anchor. So we've got L is equal to negative 2.4 T plus 75. Okay? And it says the variable L models the anchor's elevation in meters relative to the water surface 2 seconds after the ship drops its anchors. Okay, so basically this negative 2.4 T is how slowly the rate of speed at which the anchor is falling. Okay, going down, descending, and it starts at 75 units of distance, which is meters, above the surface of the ocean, basically. So the ship has its anchor 75 meters above the ocean, and then it starts declining or descending at 2.4 meters per second down, okay, into the water, and then into how long it goes to hit the ocean floor. It says, what is the initial height of the anchor? And so the initial height of the anchor is going to be that y-intercept again, right? That's going to be where it starts. That's the initial height of the anchor. It's going to be 75. And that's it. All right.